Thanks for joining the Trilithic webinar series. My name is Tony Holmes. I'm the Applications Engineering Manager. Today we're going to talk about signal leakage made easy. You'll notice on your screen that there is a chat feature provided for you. If you have any questions or anything that you need a little more clarity on, you can simply chat the question, and I'll respond to all of the chatted questions at the end of the presentation. As a webinar outline, we're going to discuss leakage terminology, just some of the terms that's used to describe leakage or that's used as you're talking about signal leakage. We're going to talk about what is leakage and why do we monitor for leakage? What are some of the causes for signal leaks? And then the specific leakage characteristics. And then we'll dive into locating the source of the leak. And then we'll talk about how to automate some of the signal leakage procedures. So leakage terminology, some of the things you hear egress, leakage, ingress, the UV/M, which is microvolts per meter, the squelch, which is how sensitive the detector is for your leakage gear, calibration, making sure that your meters are calibrated, and tagging. And then one that you just seen that just grew a lot larger is a term that was used a while ago was radiation. And the term radiation kind of got a little bit of bad press just because of the fact that when you tell a customer that you're detecting for radiation, it definitely sends alarms out to them. So we never say that anymore. I would say the appropriate term is signal leakage or egress, but most will understand signal leakage or RF leakage. So what is signal leakage? By definition, it's the undesired emission of signals out of a HFC network. So it's out of a actual hybrid fiber cable network is what signal leakage is. You'll hear the terms both ingress and egress. Ingress is signals that leaks directly into the coax or into the cable plant. Remember, your coax is designed to be a sealed network. You have an RF shield or the ground. You'll have, depending on the type of cable, if it's drop, you'll have the braid and aluminum, or the aluminum jacket. If you're doing 500 or a trunk or feeder. So ingress is signals leaking in because of that being violated. That particular shield cracked or has it's violated in some fashion or another. Egress is signals leaking out. That's what can be detected by your signal leakage detectors. Which brings up a few questions. Why do we monitor for leakage? Reason number one to monitor for leakage is to prevent off-air broadcast interference. The thing is, when signals leak out, there's a strong chance that outside signals will leak in as well. So if you have a channel, let's say if you have a VHF channel at channel 4, but you also have a cable channel at channel 4. The thing is that if those signals, if you have ingress coming into the cable, then it will try to take over that cable station, and you'll see the two channels trying to run together, which it usually calls like some horizontal lines on the screen. And that's all from off-air broadcast interference. So the spectrum chart that that the FCC wants to see us make our measurements is between 108 megahertz and 137 megahertz. So right above the FM band. So it's channels 98, channel 99, channel 14, channel 15, and channel 16 are the channels that that we measure for our signal leakage for the FCC, the CLIs. Which brings you to reason number 2 to monitor for leakage is to meet FCC compliance. I talked a bit earlier about CLI. CLI is the Cumulative Leakage Index. This is what the FCC wants to see. These are the results that needs to be turned in to the FCC for them to make the determination if your system is considered passing or failing from a CLI or from a leakage standpoint. CLI is the net effect of the combination of all the leaks that's in the system added together. And these cumulative leaks form an invisible cloud of unwanted RF energy over the cable system, which creates problems for aeronautical communications. If you have a plane that is flying across an area, and if signal leaks are strong enough, then it could interfere with them, with the pilots communicating or talking with the towers. So the CLI Quarterly Rules. The quarterly rules are write out 100% of your system and log all leaks. Log all leaks. The logs, when you're logging your leaks, it needs to include the date that the leak was found and the date that the signal leak or the leak was fixed. Now, for your quarterlies, documenting the leakage level isn't required for this particular drive out. Now, this is just talking about what the FCC wants to see. Now, you may have different procedures at your system, and by all means, you want to follow those particular procedures. But for your CLI quarterly, that the FCC wants to know that you're driving, that you're monitoring your system, checking for leaks and leaks that are found, and wants to make sure that you're making the repairs in a timely manner. And like I said, in your system, you could have different policies or procedures than this here. But now the annual rules. So what the FCC wants to see annually is write out 75% of the oldest part of the system, and log all leaks locations and the measured level. And we'll talk about how to properly measure the levels for a signal leak when it's turned into the FCC. It must be performed within a reasonable period of time. That's the wording that's in the FCC guidelines, that repairs must be done in a reasonable period of time. Usually, that can be interpreted as within 2 weeks of the due date. Now, keep in mind now these procedures could vary, especially depending on the size of the leak. If you have a 20 microvolt leak, then I'm not going to be as concerned. Or let's say if it's a 50 microvolt leak, I'm not going to be as concerned with that leak as I would be if it was a 1500 microvolt leak. So your required actions: all leaks at 20 microvolts per meter must be logged and fixed. But only leaks above 50 microvolts per meter are used in the CLI calculations. So even though you're required to log and fix 20 microvolt per meter leaks, that's the threshold. Just remember, when you're turning in your leaks for the CLI or for the FCC, then it's going to be 50 microvolts or greater. That's going to go into your CLI calculation. And all measurements taken outside of that 108 to 137 megahertz has to be converted as if they were taken within the band. So you can't just arbitrarily take a channel, instead of measuring at 130, 132, you make a measurement at 164. You don't want to do that. If you do, then you need to convert that particular number so that you know what it would be if you measured it at within the 108 to 137 meg. So microvolts per meter is the standard unit of measure for CLI. It's a 50 ohm off-air measurement. And voltage developed in 1 meter of infinitely thin section of wire submerged in a leakage field produces 1 microvolt of energy. So it kind of gives you a perspective of what you're measuring when you're measuring a microvolt per meter for your CLI. So reason number 3 to monitor for leakage: it eliminates ingress. Eliminates ingress, because remember I mentioned that if signals are leaking out, there's a strong chance that signals are going to be leaking in. It improves your system performance, because when signals leak in, then that can affect your carriers that's present, and it reduces repeat service calls. Reason number 4 to monitor for leakage: to locate physical problems within the plant. The thing is that that there's times that you'll have those intermittent issues that happen, throughout your network, and just doing signal leakage will pinpoint a lot of times some of those problems. For example, let's say you have a damaged piece of feeder because of maybe the street department just put in a new stop sign. Or maybe a customer just added a new mailbox post and they nicked the cable. Now, when they nick the cable, it may not be enough to cause an outage, but it can be enough to cause signals to leak out. And when that signal leaks out, if you're doing a routine signal leakage plan, you'll come across that, and you'll potentially fix problems before the customers even know that there is one. So some of the common causes of signal leakage: 70% of all leakage is caused by problems between the tap and the entry to the house. So it's that drop. About 70% comes right from the drop itself. And that's anything from, just, aging and environmental stresses that's on your coax. Physical trauma to cables or connectors. Loose drop connectors. Inferior quality coax cable, passives, or connectors. Some other causes of signal leakage: improperly installed connectors. Connectors that were put on and you didn't follow, and the directions wasn't followed specifically as far as the how far to cut the jacket back and things of that nature, or when it was the crimp connectors not crimped on well, or for your compression fittings, if you didn't make a good compression, you didn't hear the nice snap at the end. These are types of things that could cause signal leakage. Cracks in the trunk or feeder. You'll see this a lot of times, well, both aerial and underground. You'll see it a lot on the underground is from if your tap is not bolted to your pedestal and just from moving it around, or sometimes you'll get the feeder have a tendency to kink over the edge of the pedestal itself. And then once you try to straighten that out, it'll cause a crack. So those are leak points. It's that shield has been violated. Animal chews, whether it's squirrel chews or what have you, those are you see that a lot of times out on your utility poles, to where squirrels will chew right on the coax. They love the coax. Poorly shielded drop cable. If it doesn't have very much braiding or foil in the coax itself, signals will have a tendency to leak out because there's not enough shielding to maintain the signals that's inside. Bad connectors at the tap. Bad or loose port terminators. You'll find that most of your signal leaks, when you start troubleshooting them down, a lot of times they'll come from loose connectors. Loose connectors are huge issues. That's one of my personal pet peeves, is making sure that whenever you put a connector on, that you snug it, that you tighten it up to where it doesn't vibrate loose and things like that. You want to make sure that you tighten your connectors. And then corroded connectors. And the list goes on. Some other issues or other causes of signal leak is customer installed equipment. Customers love to help you out. They love to install their own cable. They love to put their own equipment on there, and as far as they're concerned, that they're master technicians. But unfortunately, we know that they don't have, in most cases, the proper tools to do the job properly. So ultimately, it ends up turning into a signal leak. Damaged amplifier housing or loose amplifier housing lids. Make sure that your amplifier housing lids are snug. They have an RFI shield going around the housing itself, and when that amplifier is loose, it allows those signals that's inside of the amplifier housing to leak out. Broken tap ports. When you see broken tap ports out there, they need to be replaced because they will cause you signal leaks. Poor installation of splices and connectors. Poorly shielded customer premise equipment, televisions that aren't shielded very well, the tuners, you'll have problems with that. Even VCR jumpers, VCRs that are not shielded well. I mean, the list goes on of different things that can create you signal leaks. So the acceptable procedures for leakage measurements are: you want to use a calibrated half-wave dipole antenna, and I'll show you what that is here in a little bit. The antenna must be elevated 3 meters or 10 feet off the ground and positioned 3 meters from the leakage source. And that's what FCC wants to see. That's what the FCC calls a proper leakage detection, is making the measurement 10 feet away and 10 feet off the ground. And then you want to rotate the antenna or the dipole on its horizontal plane. Just rotate it 360 degrees so that you can peak on the signal level, or peak on the amount of signal that's leaking out. Or the CLI flyover is acceptable practice also. A lot of systems have moved to doing the flyovers just because, one is it's less expensive, and it's actually a pretty quick procedure because it just requires, an aircraft to fly over, make a few sweeps over the top of your network, and then they can plot that out, what the actual CLI is. So I talked about the dipole antenna. A dipole antenna has the two elements that comes off the side of it, and I'll talk about what the pickup pattern is. So it's the dipole antenna, and then you have the monopole antenna, sometimes called the whip antenna, or if it's on the leakage detector itself, it would be called the rubber ducky antenna. So for the whip antenna, or the rubber ducky, and no, I did not make that up. The rubber ducky antenna has a pickup pattern of 360 degrees around the antenna element itself. So you can kind of see in the drawing what the pickup pattern is. The actual null point, the point to where you have the least amount of pickup, is from the tip of the antenna, or the monopole antenna itself. Now your dipole antennas picks up on either side of the elements. So you can see from the drawing. And the null points on those are from the ends. So if I'm facing the antenna or the dipole towards the leakage source, if I walk towards that particular source, my signal should increase. The way that I would, remember I was talking about rotating your antenna 360 degrees. When I rotate that, I can peek out the direction that the signal leak is coming from. And then when I walk that direction, if my signal increases, I know I'm going the right way. But if I walk that direction and my signal starts to drop out, then I know that the leak is directly behind me, so I'll turn around and walk the other direction. Now, some of the characteristics of signal leaks, one thing is called signal phasing. Signals can reflect off of structures. So you can be fooled by thinking that the signal leak is at one point in the plant, when really you're just catching the reflection, and the problem could be coming further upstream from where you're at, or further downstream, depends on where the direction of the reflection. So so you want to make sure that when you're walking with your dipole, that you're walking to the point to where it peaks out at, so that you know that that's where the actual leak is coming from. You have what's called standing waves. Standing waves is when your leak, or your signal leak, ride the strand, or the shield. So what happens is that the leakage source, like in this example, could be coming from the point right at the utility pole there, but as you notice, you can see how the signal will travel down the strand itself. But if you're using your dipole properly, you should when you're walking the direction of the leak, you should see the leakage intensity level grow. Now, one thing that can happen, your signal level meters can be tricked. One of the ways that your leakage detectors can give you false results is from electrical noise. Electrical noise can come from anything from transformers. They can come from spark plugs in your vehicles, or spark plug wiring, appliances. These types of things create electrical noise, and that electrical noise is in the frequency range. It goes across the spectrum, but you'll see it in the or it can be detected in the areas where you're doing signal leaks. So there's times your leak detectors will go off, and you'll be like, I know that there's not a leak here. I don't even have cable at that location, but it could be because of electrical noise. Now with Trilithic, we actually have developed a few different ways to combat that. One is in the Searcher series with the GT noise discrimination, which the leak detector itself has the ability of digitally determining if it's a true signal leak, or if it's something other than a signal leak or an RF leak. And the same with our seekers, which we'll talk a little bit more about that later. But the seekers also has the noise discrimination on it as well, so that it prevents you being tricked. There's also things called taggers, and taggers will also aid you in not being fooled by something that appears to be a leak but it's not. Trilithic has the CT2 and the CT3. Those are both channel taggers. The CT2 works directly off of the head-end equipment, the modulator, and the CT3, if you do not have a modulator or a particular channel at that particular location, then you could use a CT3 and it generates that RF carrier. So your leakage field strength is highest closest when you get closer to the amplifiers. Just because you have a stronger signal level coming out of the amps. I mean, coming out of the amps, you can have levels, as high as, 45 or 50 dBmV coming directly out of the amps. So you can imagine if you have a crack there in the cable, you're going to have a stronger leak coming out of there than if it was towards the end of the line, to where you may only have 30 dBmV coming out of the feed, or if it's coming out of the tap port, you may only have 20s or 15s coming out of the tap. Now remember, I mentioned earlier that all of your measurements needs to be made at 10 feet away from the source, and then 10 feet elevated off the ground. If you're not at 10 feet away, then you need to add a distance correction. The way that you do a distance correction, you take whatever the microvolt reading is that you see times the total distance divided by 10 gives you the corrected reading. So this is kind of gives you a drawing of how that calculation works. So let's say out at the truck, I'm measuring 2 microvolts per meter, but I'm 100 feet away from the cable. So we'll say in this case it's a rear easement. So it's 100 feet away. So 2 times 100 is 200 divided by 10, which puts that at 20. So your reading that it would be if you were right there at 10 feet away would be 20 microvolts per meter. So make sure that you're putting the calculation in there, because that's important when you're making the measurement. When you're walking out the leak, using your dipole antenna, remember you're spinning at 360 degrees on its axis. You want to walk, 20 to 30 feet in each direction, just so you can pinpoint where the leak is coming from. And if you walk in that particular direction, it'll point you exactly or very close to where the leak is, because of the fact that that you've pinpointed, you've faced your dipole right at the source, and the signal intensity will grow, and you'll see that that's where the problem is coming from. So we talked about egress. Ingress is just the opposite. That's the signal that's leaking in, like off-air antennas, CB radios, ham radios, just electrical noise. That's all ingress. Now on analog channels, ingress causes lines and pictures, ghosting, you name it, high-speed data problems, interference with two-way radio services using the same frequencies that you have, and it's a huge call, or it causes repeat service calls. Now digital has a different effect. You'll see when there's ingress there, macro blocking, freeze framing, picture and sound can go to a black screen, robotic voice. data packet loss or slower speeds for your high-speed data, and repeat service calls. So why and how to check for leakage? The whys is for public safety. Potential interference with aircraft communication. I mean, if your leak is high enough, it can interfere with their communications, and that's definitely frowned upon. The cable system could interfere with off-air signals as well. The quality of service. Ingress impairs picture quality. Ingress or signal leakage, egress, usually is a sign of a pending equipment failure, that there's some equipment that's about to have a problem. With the increased implementation of services requiring return path activation, if a system has egress or signals leaking out, it will most likely have ingress as well. Ingress brings the viability of two-way services into question. And voice over IP demands higher network reliability. So some common leakage sources are splices and fittings, similar to what we talked about. Water and weather can result in pulled out cables pulling out of connectors or loose connectors. We'll call those suck outs. Corroded fittings or splices at the taps, line extenders, splitters, illegal hookups, and involving twin lead cable. We kind of see it all on the cable out in the cable field. 15% jumpers from drops to taps or ground blocks. About 15% of those are causes of leaks, and then 75% is just from leaks coming from the subscriber's house itself. Now, the recommended frequency range is 108 to 137 megahertz. Anything outside of those frequency ranges needs to be converted as if you were making the measurement between the ranges there. The measurements must be repeatable. The dipole has to be raised 10 meters or 3 meters off the ground, which is equivalent to 10 feet. Dipoles should be rotated around the axis, the vertical axis. Other conductors must be 3 or more meters away from the measuring antenna. You don't want anything too close to the antennas, like your whip antenna on top of your truck. You want to make sure that that stuff is at least 3 meters away from the measuring antenna, just so it doesn't affect your readings. The measurement range should be free from obstacles. Greater than 20 microvolts per meter at a distance of 10 meters needs to be measured, and repairs need to be made. But remember, 50 microvolts or greater is what's actually calculated as part of your CLI. So this is a typical or one type of signal leakage detector. This happens to be the Super Plus, and this just kind of shows you just kind of around the screen there. You have your where it has at the top right the external antenna input jack. That's a BNC connector, a 50 ohm connection. That's where the rubber ducky antenna is going to go on. You have your on-off switch, battery indicators. You also have your detector mode, whether it's in hold or norm. When it's in hold, then it'll hold that measurement for a few seconds, and then it'll let it go. That's very useful if you have your leakage detector docked in the truck, that you can quickly glance over and see what the leakage level is, but just make sure that you're safe when you do it. There's also, you'll see to where the battery check switch is. It's to the right of the hold button. In this particular unit, because it has the super mode and then it has a SCH plus, The SCH Plus is looking at it without any of the digital circuitry, the noise discrimination, with none of that in there. It's looking at, what you see is what you get. When you put it in super mode, if you have a tagger, then it's going to lock directly on that tagger or use the noise discrimination. At the very far left, you'll see a sensitivity button. That's the scale. That if it's on a ×1, then what you measure is what you get. So if you're looking at the meter scale, if it was at 5, if that's where the needle was pointing, then it's a 5 microvolts per meter. But if you put the ×10 on there, then instead of that being 5, it's really a 50 microvolt per meter. So now there's doing signal leaks has advanced so far. I mean, there's everything was always, you had to document it on paper and, turn it in at the end of the day, and then work orders are generated, it goes back out to the field, and it was a pretty lengthy process. But at Trilithic, we designed a platform that actually makes that whole process a lot easier. It's a lot more automated. And we do that with what's called Seeker GPS. What Seeker GPS does is it stores the data on the MCA, which is at the upper right. It's equipped with GPS, so whenever you're driving out your signal leaks, it's going to put a GPS coordinates to it so you know exactly where the leak came from. It has Wi-Fi upload capability, so you could park your truck at the end of the day, and your leaks will be pulled off of your truck or from your MCA automatically. It has MapQuest mapping, so it actually plots your leak directly on a map. And it's server based, so you're able to archive all of your signal leaks. It keeps record, and this is what you would use for your CLI. So this is kind of the components that builds up a Seeker GPS system. You have at the upper left the law client. That's the portal to look at the law server that houses all of the signal leaks. And that's also the server is where the mapping is, where it's being generated from, or the work orders are being created from, and so on. As you go clockwise, you have the Bluetooth or serial GPS. We primarily use the serial GPS now, but with the serial GPS, you can plug directly into the MCA, and you will be able to, whenever a leak is detected, there would be a GPS stamp that's placed on that leak. There's the law server, which, as I mentioned, houses all of your leaks. That's the storage spot for all of your leaks. Your MCA, that's what stores all of the data. That stores your data. The BB2, that's the black box. What the black box is, it's really the Seeker and the MCA all combined together in one box. I mean, I've heard of systems wanting to use something like this to maybe equip the postal trucks, or because they drive out your down every street, that they could be documenting leaks all the time. Or you can put it on every installer's vehicle to where they're not having to. It's kind of out of sight, out of mind, and it allows them to just drive and just do their work as they normally would. But behind the scenes, the BB2 or the black box will be documenting any leaks that they pass, and they don't have to do anything when they park their truck at the end of the day. Then the leaks are just automatically, via Wi-Fi, can just automatically be pulled off of there, and work orders can be distributed the next morning. And then there's the Seeker. The Seeker is what what actually detects the signal leaks in the seeker GPS system. So when you're preparing to check for signal leaks or getting ready to drive for signal leaks, you want to make sure that your seeker is secure in the cradle. You're going to make sure that that you get there's some letters and numbers that come across the screen. It's a CA0. It'll come on the screen briefly and then it goes away. That lets you know that you have that you're getting a good lock, that it's docked properly in the docking station. You want to make sure that GPS is displayed solid on the seeker. And these are checks you want to do before you start driving around, because there is nothing worse than driving all day to find out that, wow, I did not have my leakage detector docked properly, because it's not going to pick up what you drove. And then you want to make sure that the proper frequency is selected for the drive out, because this is an agile leakage detector, so you can put in multiple frequencies, but you want to make sure that you're actually measuring the leakage frequency that is set up for that particular system. So we talked about the CA0. Remember, after placing the seeker in the mobile mount and upon successful communications with the MCA, the seeker will momentarily, it's just going to flash on the screen, and then it's going to go away showing CA0. Remember I mentioned about the GPS, where you want that solid. That lets you know that the GPS is actually working. And when the icon is not shown, the seeker is not in the mobile mount, or the GPS connection cannot be established with the MCA. If the icon blinks, the MCA is connected to the GPS, but the GPS does not have a good position fix. So it's still trying to find a satellite to lock on. So when you're driving, leak level and location is automatically collected. It's done automatically when it's properly docked. And the tech, when you're driving, can visually monitor detected levels to ensure that major leaks get immediate attention. Because, like I mentioned earlier, is that if there's a 20 microvolt leak, even though that's something that needs to be repaired, but it's not going to be as much of an emergent issue as if it was a 1,000 microvolt leak. So, and then once you go all the way through and do your leaks, I mentioned, the ability of making it totally automated, to where when you park your truck at the end of the day, that via Wi-Fi, that the information is pulled off of your MCAs and it's sent back to the server. You can also do the same thing by manually by pressing the snapshot button, and I'll show you that here in a little bit. The snapshot button, and it will sync the MCA, and it'll sync everything from the MCA to your leakage detector, your seeker. And once it syncs everything to there, you can take your leakage detector out of the cradle, and you can take it inside, and you can download the information to the server. When that synchronization is complete, then on the screen it's going to say that it's done. So this is kind of what I was talking about for the manual upload, to where you have your GPS, your MCA. You want to do a sync. You want to sync your MCA to your seeker. Once you sync the MCA to the seeker, then all of your information will be pulled from the MCA, and it's going to reside on your handheld. Then you can remove the seeker directly from the cradle, and you can take it to a local PC that's on the internet, and you can tie and pull the information directly off of your seeker, and you can put it via the connection there the data will be extracted and it will go right to the server. For the Wi-Fi, it's a lot more automated. That all you have to do is park your truck and get out. That's all it takes. You can set how long your truck needs to be parked in its particular Wi-Fi hotspot or that home zone, how long it's going to park in that particular area before it starts to do the upload. And then once it sits there for that particular period of time, it'll automatically pull the data from your truck, and you don't have to actually mess with it at all. So kind of the data paths you can kind of see on the drawing that the leaks go to the MCA. The MCA in the truck is kind of the center point of the GPS and the seeker itself. So it's marrying the leakage, the microvolt reading data with the GPS coordinates. When that's on the MCA, then via Wi-Fi, port 24007, it sends the data directly to the law server, or you can manually go directly to the server via a local PC. So the seeker GPS communications, data upload paths. Through a manual upload process, data from the seeker uploads to a client application. The client application then forwards the data to the law server via the internet. Now, in the automated method, the seeker GPS MCA uploads records through a customer configured Wi-Fi access point to, and then the data is sent directly to law. The server operates and supports the software. The client, there's the client software, which is the local holding point for data uploaded from the seeker. And then there's a forward data to the law server via the internet. It forwards the data directly to the server. And then the law server itself holds all the data collected from the seeker GPS mobile installation. And the it processes the data, summarizes the leak cloud, which is the leak that is found there, displays data on the maps and in the reports. It outputs the data records for other map or work order processing applications. And then there's also the seeker setup that sets up the seekers so that it's measuring on the right frequencies, and that you're if it's supposed to have a tag tag frequency, it sets up everything on the seeker itself. And it also, with the seeker setup, it sets up the MCA. So once everything is finished, you did all your leaks, everything was well. You did everything. All of your information went back to the server, either via Wi-Fi or you did a manual sync. And then you want to now distribute work orders. So as leaks are uncovered, work orders will be assigned. So when leaks are found, you will get work orders assigned to the technicians assigned to a specific leak territory, or to the supervisor responsible for the area, because sometimes the supervisors will get all of the work orders and then they distribute it accordingly. And all of the work orders are sent via email. So the techs can act on a leak reported via the email, take the appropriate action, do the pre and post fix. We'll talk a little bit about that. Snapshots, upload the data, and then they can close the work orders out themselves, depending on how it's set up. And the work order sent can either be sent to a designated person via the email. The email is the way that we communicate with the person that's tasked with making the repairs. So this is what a typical law, when you're looking at the law site, what you're going to see is you see a what looks like a MapQuest map, and it is because it is a MapQuest map. It shows the map interface. You can sort all of the leaks that are on that particular map. And then there's a spot to where you can create a work order. That's if you were doing the work orders manually. If it was automated, it would do that for you automatically. The other thing that's nice about the law is that not only can you look at it from a street level view in MapQuest, you can also do a hybrid map or an aerial view of where you're getting ready to make the measurements, because sometimes you can make a determination what the problem might be before you even go out there. For example, if I see an area that I know that there's not any cable out there, and I can look right out there, and it's in a remote farm field, then I can say that, okay, that must be some noise that's out in that area, and that's probably what it picked up. The work orders are then, I remember I mentioned that you receive your work orders via email. You'll get a work order, and it'll show you where the leak is, and it'll give you what the address is of that particular leak and what the microvolt reading is of that particular leak. In this example here, if you look towards the bottom, it shows that the microvolt per meter reading for that one dot that's on this work order is at 200 microvolts. And you could also print out an actual MapQuest map giving you drive-by, step-by-step directions to get to that particular location if you wanted to. So the step that you're going to do is once you go through and you've measured your you have your work order, you're getting ready to measure your leak. You have your dipole antenna at 10 feet away from the leak and 10 feet from the ground. What you're going to do is, before you actually make the repair, when you identify that yes, there is truly a 200 microvolt per meter leak here, then you want to hit the snapshot button on the meter, on the leaks detector, and it's going to put a prefix measurement. Once you make the repair, after fixing it, you do a post-fix. And that's going to give you what the microvolt per meter reading is after you made the repairs. So then through this process, the leakage map in law has become a virtual, real-time presentation of the leakage condition of the cable plant. And by doing your pre and post fix, depending on how you have the system set up, the work orders can be closed out for you automatically. So here's the snapshot button that we were talking about. It looks like the yellow button there with the camera. When you press that, that's a twofold button. When you, if it was in the cradle, with the, and remember when it's in the cradle, it's tied to the Seeker MCA, and also the GPS is tied to the MCA. When you hit the camera button, it's going to do a sync. So it's going to sync your information or your data from the MCA, and it's going to put it back onto the Seeker. If it's out of the docking station and you're making a measurement out at the leakage source itself, when you hit the snapshot button, it's going to give you a choice of either a prefix, post-fix, or to just cancel it. So this is what it looks like. If it's a prefix, it's going to say PRF, which is for the prefix. That's what you're going to take before you actually make the repair. Do a prefix snapshot. After the repair, after you've verified that everything is nice and good, now you need to document that the leak is taken care of. You want to do a post fix, and it's going to come up with a POF. So hopefully you were able to gain a little bit more knowledge about measuring signal leaks within your cable plant, because that's, I tell you, if your plant, if you keep that as tight as you can and as the least amount of signal leaks, to where that's at a bare minimum, you'll be surprised at how well your system will perform. And especially with the extended services that you offer now, whether it's with high-speed data, your digital tier, your voice over IP, video on demand. I mean, there's so many things that relies on a good, clean, whether it's return path or a good, clean digital, QAM signal downstream. Ingress will impact that, and when customers are paying, extra dollars for these extended services, they're just not as tolerant of the services not being there. I'll now respond to some of the chatted questions that came across. All right. There was actually a whole lot of information that was given out, and I did receive some questions that I'm going to go ahead and address now. One of the questions is that it says, I've noticed an issue with my air card on my laptop causing leakage on the meter while it's in the truck. What can I do to correct this? One of the things that you want to do is that whenever, just remember, leakage detectors, it picks up whatever it hear, and air cards can trick the leakage detectors. But if you have a channel tagger, channel tagger will allow the leakage detector to lock directly on that tag frequency, and if it's not the tag, then it disregards it. It says that it's not a leak. Also, it was a question about the black box. Do you need to have a seeker? No, you don't. The black box is a standalone unit that is, kind of look at the black box as a seeker and MCA all combined together. So it's like the seeker without the digital display on it. And once again, that's useful for just installing in each of the vehicles, and they can just drive around and not have to worry about what's actually going on as far as the leak. It's doing all the work for it. As far as a question about recommendation for antenna calibrations, I always recommend having a calibrated leak point at each of your locations. So usually, like at where your parking lot is, it's good to have it to where the truck can go right up under it. The leak will be, 10 feet away, usually at about 20 microvolts per meter coming out of the antenna itself when you drive under it at 10 feet. That's the best way to verify that your unit is calibrated. If you truly want to know how to calibrate the antenna itself, that would be the verification process. There are different cut lengths for your element on your antenna. If you want some specifics on that, feel free to call our support forum or our support line at 1-800-344-2412, or send an email to support@trilithic.com. But usually, when you get your leakage detector, you want to have your antenna already cut and tuned from the factory to verify that it is properly set. And this particular presentation, it will be offered on demand. So if you need to have a refresher on it, or if there were those that were not able to join in on this particular session, on our website, there's a link on there that has all of the trainings that we've done so far with the webinars. But you can always feel free to send me an email directly, which an email will be coming to you from me, and you'll have my email address, but it's tholmes@trilithic.com. It says, can you or do you need to calibrate the seeker? That kind of goes back to the calibrated leak to verify that it's calibrated. There's no field calibrations. If your leakage detector is out of calibration, then it would need to be calibrated at the factory. Can the Super Plus be connected to a dipole? Yes, it can. When you're doing leaks, the Super Plus will work off of the dipole antenna in place of the rubber ducky. Let's see, then it says, where's the new, kind of reading these as I go. With the new SEP 48, how are we supposed to tag the RF? The thing is that this gets a little bit tricky. This may be something that that you can feel free to give me a shout directly, and we can talk a little more about how to use the tagger or when to use a tagger. Because whenever there's certain, if there's energy that's present, or if it's a digital signal or things of that nature, then you don't want to implant something in there. So it's good to have a channel that is dedicated to leakage. Then there's tuning the resolution of the black box. I'm not sure exactly what that is, but feel free to get with me offline on that to kind of give me specifically what you're asking about there. Let's see, there's a few more questions. There's a questions, even if I don't use the products, can I share with some questions, problems regarding cable activity? Yes, you can. Yeah, you can give me a call offline or shoot me an email, and I can answer any specific questions that you would have. And there's been a few questions about, will this session be available later for viewing? Like I said, it will have it online. Yes, it will have that online, so you'll be able to stream that to your location. If you have troubles finding that on our website, after you go in the broadband instruments, there will be a link on the side that takes you to all of the trainings. Feel free to shoot me an email, and I can shoot the link directly over to you. Then it says this is a secret question. After your snapshot out of cradle, what happens to the data once you dock it? When you do a snapshot with the seeker, let's say you went to the pole and you did the snapshot, the prefix, the postfix, as soon as you dock it, it automatically pulls that information, it tags it with the GPS coordinates, and then it puts it in the MCA. Question is, the maps are only for the USA? No, it can actually, there's maps, for international as well. Yeah, so that's something that if you have a specific location, feel free to give us a shout out. In fact, we can let you know if there's any areas that's not included. But we do get our mapping base from MapQuest. So, question: can I find and fix a leak with the black box? What you can do, it's going to actually just document all of the leak sources, so that when you park at the end of the day, it's going to send all of the leaks back to the law server, and then work orders can be printed out. It's always a good thing if you're an installer or something along those lines to still have a leakage detector, whether it's the seeker or if it's the seeker light or something like that, because it's still important that when you complete an install, that you want one of the last steps that you do when you're finished with the install is you want to walk around the perimeter of the house or where you did your outlets and around the utility pole, just to make sure that there were no leaks found, or that there's no leaks there. And then it's how do you calibrate the seekers? Feel free to call our support or for our repair, and those can be calibrated at the factory. Let's see, we're almost done. The black box needs a GPS, or is it built in? No, the GPS is external. There's it would plug into the black box. So there's one. When I go in the field to repair a leak, my screen says 16 microvolts. I come back and upload my seeker. I get an email saying that it was 128 microvolts leaks per meter. One thing to understand is with law, it actually looks at what the real value is right where you're at, or right where it says that the leak was actually coming from, because it does what's called quadrangulation. So it's actually taking multiple points and it's summing that up, and it's pinpointing where the leak is coming from, and it's also saying where the actual, or what the actual leakage intensity is. So that may be some of the reason that it's reading a little different, but feel free to give us a call and we can drill into a little bit more, because there's a few other scenarios that we can check out to make sure that that is the case. Is there a carry case? Yes, there is a carry case that you can have the seeker in as well. Since my alarm does not go off when it's supposed to, I have my volume turned up. I can't read my snapshots on the computer. Doesn't seem to be working. Now, what that could be, and this is something that you would may want to take offline as well, because if for some reason, if you have your leakage detector set up to look for a tag, and if it's not, and the tagger is not there, or if you tell it that it's a 20 hertz tag, but really it's 15 or it's 23, then what'll happen is it doesn't see that, so you won't ever sense a leak from the leakage detector, even though the MCA will still track all of your leaks, and that's if it's on the seeker. See, suppose you find a leak from a customer. How can you make the client to change cables in the home? That's actually a very good question. You just tell them they have to. No, that's really a very good question, and one that a lot of people face. I think one of the important things is to explain to the customer that not only is signal leaking out, but their signal is leaking in, and it will affect their picture quality if the cables aren't rerouted in the house. And a lot of times that gives them more of an incentive to want to have the wiring changed, because now it actually affects them. Let's see. Does a seeker have an internal GPS? No, it doesn't. It's all external, tied into the MCA. And we're just about done. Okay, yes, if as far as any specific questions as far as with the taggers or the leakage detectors in general, or how it actually works, or if you need more training or additional details, feel free to give me a shout offline, and we can take care of that. I'm going to answer just a couple more, and then if you would, feel free to send me an email. Let's see. Okay. Okay. Yeah, there was a question about the tagger again. There's a lot of times with the tagger, the questions come up a lot. As far as setting them up and making sure that they're set properly, and then making sure that it's truly that your detector is locking in on that particular signal source. Like I said, those are things. Feel free to give me a shout offline with that. Yeah, there's another one about the channel tagger that it picks up the competitors. So yes, yes, if you would, Tim, give me a shout if you have some specific questions, or email about that. I think that'll we'll be able to talk a little more specifics. All right. Well, I appreciate everybody hanging in there. I know I went over a lot of material, but the leakage, it's so important that you keep up with your leakage, that you don't let that fall to the side, even with going with more, your system's going to more digital digital signals, still my recommendation is always leaving a space, leaving a channel reserved for your leakage, just because of the fact that when you have a good leakage program, it's also going to positively impact your digitals and all of your other channels, because you're going to be preventing ingress from being able to come in. Well, I do appreciate it, and keep checking online and as for other webinars that's coming, because we have some other hot topics that's going to be coming across the board, and I want to make sure that you have an opportunity to join in. All right, thanks.